Alright folks, this is Systems of Linear Equations Part 3, I think. So if you're learning this stuff, you've probably done things like this. X plus 2y equals 3. 4x plus 5y equals 6. You know, integer coefficients, that's great and all. And you've probably done, if you've followed the videos, throw in some fractions. 1/2, 2/3, 3/4 of 5, 6 plus 7/8, 8/9. You know, two variables, two equations, and the coefficients are fractions. And hopefully that's helped you do your arithmetic with fractions. So these fractions, those are called rational numbers. It's literally a ratio of two whole numbers or integers, hence rational. Well, let's do the same thing now with irrational numbers. So here's a new problem we're going to solve together. So square root of 2, square root of 3. No, I'm gonna do pi. All right. Remember, pi is approximately 3.14. Right? Equals, I don't know, E. Now y'all might not know E. What is E? It's not a letter. This is a symbol. So let me give you E. It's called Euler's number. I know it looks like Euler, but it's Euler's number. And it's like 2.7 something. It's kind of like pi. It's an irrational number. And side quest, very important. Let's look at it. This is the number E up here at the top. What if I get a cursor? I just got a keyboard for this iPad. Really cool. I can point at stuff. There we go. E. This is not what it is equal to. They are lying. That's what it's approximately equal to because they rounded it off. Because remember, decimals are fractions. So yeah, 2.71, whatever it was, this is the same as 2 plus 7/10 plus 1/100, or 71 100ths. See that fraction? This is not a rational number. It cannot be expressed as a fraction, therefore it cannot be expressed as a decimal, and that's why it has its own name, E, just like pi. That's the name of a number, just like this is the name of a number, a known quantity. Okay, so get your pattern recognition used to seeing this not as a variable or a parameter, it is a number. And now we need another equation, so let's do square root of x. We'll do E here. Okay, so this is going to be arithmetic just like the last problems with fractions and integers. Okay, and you might think it's harder, but I'll show you that it's actually easier. So if we're going to do our just basic addition method, we need something to line up. If we add those, they don't go away. If we add these, they don't go away. So I'm going to use non-standard notation to make it where I can add them together to make a variable go away. I'm going to multiply everything up here by the square root of 3. And I'm going to multiply everything down here by the negative square root of 2. So now these two lines, wherever they cross, are exactly the same two lines as these. If I multiply everything by the square root of 3, I'm going to multiply that by the square root of 3, the square root of 3, the square root of 3. So it's just like if I multiplied everything by 2 to get rid of fractions. Now down here, I got a negative square root of 2, square root of 3, and then a negative EY. Oh, look at that, I forgot my Y. And then I have the negative square root of 2 pi. I'm probably going to make lots of mistakes in these videos, and that's okay. So now, why did I do that? Because look at this. These are the exact same two lines as those. And now, addition method. Those cancel out. Notice I could have turned that into the square root of 6, but why? That's just extra work that doesn't need to be done. Those go away, and here, what do I have? Ew, that's kind of ugly. I got, if this was just the number 2 and this was just the number 3, it would be 2 minus 3y, right? This is just a number. That's its name. How many do we have? We have this many y's minus this many y's. That's how many y's we have, right? I just factored the y out. Over here, this is just a number. It's not a conveniently named number, but this is the only way we can actually write down the name. Y'all are used to having like that, and then you turn it into this. Well, you didn't have to. You could have just used that. That's the same thing. And in this case, you can't. You can't turn this into another name. We cannot rename this in a better way. So we're just going to leave it like this. I'm going to show you, because I'm leading up to algebra. All right, that's a number. Yeah, let me show you. Square root of 3e minus root 2 pi. Let's see. Square root of 2e minus, what was it? Square root of 3 pi. Now this is not what it's equal to. They're lying. It's just approximately. Okay, so that's around what its value is. There's just no way to write it down. To write it down for real, there would be an infinite number of digits, and there's no repeating pattern. That's why you can't write it down. But this is the name of it. Okay. You might think, that's awful. Well, this is no different than if I put 3y equals 1. Instead of the name of the number being this, this is the name of the number. Instead of the name of the number being this, this is the name of the number. So what would you do? Something like that. Fine. That's what we're going to do. So if y is that, therefore, if this times y equals that, then y must be this. Let's see if I can do this quickly. I'm still learning how to do this quickly with this new iPad. Boop. Put the line, boop, switch back, boop, paste, pow. That's our y value. So wherever these two lines cross, that is the y value. Now this is some number. I don't even care what it is. I don't need to know the value. This is the name of it. Just like that's the name of a number, that's the name of a number. There's no other way to simplify it. Okay? And I like that. That's great. So what do we do now? We need to find the x, because we want to know the coordinate where the lines cross. Great. So y'all learned substitute, right? Y into either one of these. Remember why it's either one? Here's your two lines, random lines. Well, if this is the y value where they cross, that means that's what this value is. That's the y value. And if we plug it into either one, we're going to get the x. The x on this line and the x on this line are exactly the same for that y value. So it doesn't matter which one we pick. Pick one. All right, I'll pick the first one. So if we want to, we're going to replace the y here with what it says it is. All right, replace y. Boop. All right, let me make that a little bigger. Pow. Replace the number y. because we know exactly what it's worth now. It's worth that much. And I want to know how to resize on the fly, but I haven't figured that out yet. And then what's the rest of our equation? We're replacing y, and then we have root through e. Root. Actually, you know what? These are equivalent to these. I added these symbols to accomplish this. I'm not going to use this version. You use the simpler one, this guy here. Let's replace the y with this one, because there's less symbols, less to deal with. So let's do that instead. Paste, boom. We're going to replace our y value with this guy. Copy, paste, reselect. And, all right. Now we're just trying to figure out x. Cool. Well, this is no different than 3x plus 2 equals 1. Number, number, number. They're simply different names. So how would you solve that? Subtract 2, divide by 3. Cool. That's all we're going to do here. So if this is equal to that, then this is equal to pi minus this number. I'm sorry, pi, e. E minus this number. Okay, cool. Oh, I got a little y here along for the right. There. You might not like it, but this is just a number. That's its name. You know, I could distribute the pi. If I did, I'd either put it here and here, or here and here, but not both. All right? Okay, but I just need the x, so let's divide everything by root 2. Now I could do this, but I already got fractions. I don't want like a 3-level hierarchy. So what I'll do instead, okay, is something I've been trying to get you all to do for a while. Let's multiply both sides of this guy. And again, I'm going to use non-standard notation. I'm going to multiply everything by 1 over root 2 instead of simply dividing by root 2. Root 2 over root 2 gives me x. Let's move this little guy down here. Come on. X. And I have 1 over root 2. Now when I do it over here, I'm going to do, take this guy, boop, copy, paste, boom, and there. That's it. That's the number. This is the name of the number. Sure, I could simplify it, or not.
Stop.
Yes, darling, what's up?
I love you.
Oh, I love you too, darling.
I
And what?
want to play.
Oh, play date.
I see the kid.
Well, you're going to get a play date later. The kids are going to come and play with you. I found those croquet mallets. I think you will love using those wooden hammers to knock balls all around the yard. There you go, folks. I just distributed this into there. I mean, this is the answer. It's just fine. I'm just kind of playing with it. Oops. To see if I can find a prettier way to write it. If we get rid of all the parentheses, all I notice is that if I bring this in, the roots will go away. I don't know if that's helpful or not. Honestly, I don't like it this way. I like it better this way, because what's going to happen, we're going to get pi times this, we're going to end up with pi squareds, and sure, that'll turn into a 2 and no more root 2, but here we're going to have ugly complexity. So you know what? I like the answer like this, for x anyway. Oops. What could I do to try to make this look better? Because when they say simplify, what do they mean? Simplify means apply the operations and make them go away. Well, I can apply the operation, make it go away, because I have a name for this quantity. There is no other name for this quantity.
Dad, I can't find the food coloring.
Oh, food coloring. Well, give me a second and I'll find it for you. There are tricks that can try to make that look different. I like it that these are lined up, but look, the pi's and the e's are switcherooskied. So I'm going to leave it like this. So the answer to where do these two lines cross is this coordinate.
Dad!
Yeah, baby. Can you pick up that dog food, please?
Okay.
All right, thank you. I'll help you as soon as I finish this video. Okay, folks, we're almost done here.
Can I drink some of this?
No, you don't want to drink flavoring for snow cones. That's the x value, and here's the y value. Well, you've had the snow cones, haven't you?
Yeah.
All right, well, you want to put that in the fruit smoothie? Maybe that'll make it taste good, huh? And there's the y value.
How about we make a snow cone?
If you want to, we could
Out
check
of
our work.
snow. When it snows, I'm going to make a snow cone.
Now, it might be tedious to take these numbers, the x and the y, and plug them in to this to make sure the left and the right are the same. So how about we do kind of a unofficial check here. Again, this is
It's going to taste so
what we
good.
say, where we say the lines cross these two lines. Oop. Yes, ma'am.
What happens if I snow with snow cone thing with some
What?
of this? What will happen?
I don't know, baby. Give me a second to finish this up, okay? All right.
Can I make one out?
Yeah, here in a minute. Let me finish the video. The whole world is listening to me right now, okay? The whole world. All right. Oh, I never got to finish what E was. If you want to define it exactly, you need something like this. Because what it is the bigger you make this number, here I put 10. Notice 2.59 is close to 2.71. What if we put, 100 down there and 100 up here? Look, it's getting closer, 2.70. What if we put 1,000 instead? Oh man, there. Now it's pretty close, right? So what we need to look at is the limit. Put the biggest number possible, but we can't put infinity. That's not a number. But we can graph a function and then just look really far to the right. Here's the function. If you go really far to the right for bigger and bigger values, you're going to see that it approaches e. Y equals e. See how it gets closer and closer? That's how we can define it. Now, our lines. Yes, ma'am. Oh, don't dump that out, baby. Come on, don't get syrup everywhere. Okay. Can you please give me just 5 minutes? I want to go play with her. Root 2 pi e. Root 2 pi e. I'm almost done, darling. Okay, that's one line. Now what's the other line? Root 3 e pi. Okay. Root 3 e pi. That's our other line. Where do they cross? Right here. Now, I wish I could do just a little snipping. Copy this and paste it. Maybe it'll let me. Ooh. No, I just